Okay, this video will give you an introduction to internal forces. Internal forces, if we break a structure from any point, it doesn't matter, it's a building, it's a bridge, or simply a beam like this, which is between a point A and point B. If we break this bone at point C, we would be able to see three things. Those three things, one of them is the normal force, the other one is the shearing force, and then the last one is the bending moment. So these three are at every location of the structure. If you cut it from that location, you can see it on that location. For instance, if I look at this pen, if I apply the force in these two directions, so that's called a normal force. Normal force is where the force is perpendicular to the cross section. That's the meaning of normal, right? So normal meaning perpendicular. So perpendicular. Shearing meaning that the force is parallel to cross section. So in this case it looks like this. Again, right now is a notebook here. If I apply the force like that, you see, this is a shearing force that I'm applying, because the force that I apply is parallel to this cross-sectional area. That's a shearing force. In this book, if I apply the force like this will be a normal force. There is no way you can break a book by normal force. You can go over a book with a Ford F-150. Nothing would happen to the book, right? If you consider a book like this, again, in this case, if I put the whole load on this, nothing would happen to it. Remember, it will tear apart due to the shearing, right? The shearing force is the force that you apply this way. This force right now is parallel to the surface area. The other force is perpendicular to it. That's a normal force. Now, in this case, I have a normal force, shearing force, and the moment. The moment is the resultant of, again, interaction between different forces will create extra moment here. So at point C, I would like to calculate these forces. Now, we already talked about like mini free body diagrams, that we were talking about trusses, the section method. This is very similar to the section method. We're going to cut the structure from here, but the issue is I don't know how much By is, I don't know how much Axay is. If I know one of these two, I would be able to consider that side and I would be able to do some calculation. So in this case, the point C is located in the middle here, which is going to be half a meter here. Now, I need to find, again, I'm going to draw external free body diagram for this structure. It's not needed for every problem, but for this problem I need it. So down here I'm going to have AY, I'm going to have AX. At this point I have 20 kilonewton going up. I have 40 kilonewton here going down. I have a 60 like this. And then I have the By here. Angle here is 30 degrees. So in order to find, again, in this case, I can consider either left side or right side, but it's up to me. I'm going to consider, for instance, I'm going to consider this side because I just need to calculate By. Let's do it that way, right? So if I calculate By, I'm going to do the moment about A. Sum of moment about A is equal to 0. I'm going to have 20 times the distance from here to here is 1 meter. And then I have the 40. 40 is going to go the other way, which again 20 is counterclockwise, 40 is clockwise, so the other way. 40 is clockwise, so 40 times the distance for 40 is 2. Then you can break down this 60 into two components. 60 cosine 30, which is going to be down here. 60 cosine 30. And I have on the top, I have 60 sine 30. So 60 sine 30 is going to go through point A, no moment from it. So 60 cosine 30, that's going to go plus 60 cosine 30. The distance for that is a half a meter here. And then I have 2 meter there, so it'll be 2.5 meter. And I have the By, which is in the same direction of 60. So it's going to be plus By. And the distance for that is like 1, 1, 2, 2.5, 3.5. Okay, so 20 minus 80 will be minus 20. So minus 20, 60 cosine 30 times 2.5. I'm gonna use my calculator for this purpose. So 20 minus 80 plus 60 times cosine 30 is 0.866 times 2.5. So I'm going to get 69.9 for this part. This will be 69.9. Then if you want to find by, so by will be equal to negative by is the reason that by become negative, because majority of your forces, they create a moment. Again, we have the 60, we have the 20 minus 80, that's we minus 60, but down here we have like a lot of moment created due to this. That's why the by will become negative. This divided by 3.5, I'm going to get minus 19.97, which is almost minus 20 kilonewton. So that will be the reaction at by. Now I'm going to consider, I told you that I'm going to consider the right side of the structure, and then I would consider that point C. So let's draw the free body diagram for it. Again, I'm going to have the point C here, that's point C. Between point C, after point C, you have 40 kilonewton going down. That's in the distance of half a meter. Remember, that side is half a meter, this side is half a meter. Now, the next force we have 60 cosine and 60 sine. They are like this at this location, which is going to be like at point C, 1 meter away from point C. Again, I can come in another half a meter there. 60 cosine 30. Then this side we have 60 sine 30. At point by, again, I can change the direction, because right now what I found, but I can just use it as negative 20. Just leave it as by like this. But I know this is minus 20. Again, you keep the direction of it. Then in your calculation, you're going to consider it the other way around. At point V, I'm going to have 3 components. One would be N. Again, the other one is V. V is the shearing, N is the normal, and I have a moment like this. So in this structure, how many unknown I have? I have 3 unknowns. I don't know N, I don't know V, and I don't know M. I'm going to calculate those 3. Again, just need to find, I need to have a little bit more distance. This is 0.5 meter, and then from there to here is 1 meter. So I'm going to use this diagram to so hopefully you can see the diagram. I'm going to start doing the equation. So sum of f of x equal to 0. On the x, I have minus n minus 60 sine 30 equal to 0. Then from here, I'm going to get the normal force is equal to minus 60 sine 30 will be minus 30. So what does this mean? This means the point normal force is the other way around. It's not that direction, it's the other direction. Sum of f of y equal to 0. On the y, I have the v going up. I have minus 40 going down. I have 60 cosine 30 going up. Plus by equal to 0. Now in this equation, by is minus 20. I'm going to use minus 20 here. So if you calculate v, you're going to get v is equal to minus 20 minus 40 minus 60 minus 60 plus 60. So minus 60 plus 60 cosine 30. I'm going to get minus 8 for this. is 0.04 kilonewton. That's how much I got for my shearing force. And the last one is the sum of moment. Sum of moment, I can pick a point. I'm going to pick a point about point like down here, about by. That will be good to go. So sum of moment about point B equal to 0. As we discussed before, moment about any point is 0. Point B is equal to 0. From here I'm going to get, okay, the V does have moment, but the N doesn't have moment. Again, if you want to be comfortable, don't considering the V, you can do moment about point C. Right? It doesn't matter about what point you do it. So moment about point C equal to 0. Then at this location I have the minus M. I have the M going clockwise, right? So that's why I put minus M. Or you can just simply put M. If you got the answer negative or positive, you can, but again, in my diagram is negative. So I'm going to do it like this. Minus M, and then 40 times half, and that's going to go clockwise. Then I have 60 cosine. Yeah, I have hesitate. I'm just going to keep it positive. Then if I got the negative, meaning that was the other way around. So plus M minus 40 times half plus 60 cosine 30 times 1. And then we have the BY plus BY is going to go positive. By into the distance is 2 meters equal to 0. From here, this is minus 20. This one 60 cosine 30. I got 51. Is this 52 almost? And then this one is minus 20, so you'll see minus 40. So the answer for this, M is equal to minus 8. Again, M is clockwise, so meaning that the magnitude of M is 8. You don't need to do any changes. M is equal to 8 kilonewton meter clockwise. Okay, now what would be the use of this information? The designer or the person who want to do the mechanical design, he knows the normal force, he knows the shearing force, and then he knows the M, the bending moment. They can use these three information. With the use of these three information, they can do a design. Again, I have several problems like that I can focus on, but let me just to go to distributed load. I'm going to be back to the lecture that we had.